Hey you guys, Miss All Day again. This is going to be your last new lesson for Geometry Honors, okay? And so this should be Tuesday, May the 5th. And we only have 2 problems to do. So it's going to be a real short lesson. All right, let's get started. Probability models. Data can be displayed in a two-way frequency table like the one below. So let's just look at this first table. It says the table at the right shows the number of students who passed their driving test. So here they passed it, as well as whether they took a driver's education class to prepare. So these 32 that passed it took the class. These 18 that passed it did not take the class. And then you have 7 that failed it, that took the class, and 23 that failed it that did not take the class. So you have a total of 39 people who took the class, and you have 41 people who did not take the class. And that's a total of 80 people. You have 50 people who passed the class and 30 people who failed it. All right, so let's look at the next point. What effect, if any, does taking the driver's education class have? So if they took the class, okay, we have 32 that actually passed it. All right, so how likely was a student to pass the class whether or not they took the course or not? Okay, so here we have they took the class, they did not take the class, but we're looking at the pass rate. Okay, so we have the number that passed, who took the class, over the total number that passed. Who was more likely to pass the test? So we see that that's 32 out of 50. All right, in your calculator, if you take 32 and divide by 50, that is approximately 64%. So who was more likely to pass the test? Someone who took the class or someone who did not take the class? So we know it's going to be someone who took the class. Someone who took the class. And then it says why? Because the probability for them to pass is higher. All right, so let's see what the probability would have been if they didn't take the class. All right, so let's do that in red. So what's the probability that they did not take the class and they passed? All right, so that's going to be 18 out of 50. All right, so in your calculator, we're going to do 18 divided by 50. Okay. And of course, that's 36%, because if you took the 64% and you subtracted it from 100, you should have got 36%, right? That's the probability of a student who did not take the class and passed. All right? All right, let's scroll on down. I'm going to erase some of this so we can see a little bit better. All right, so I want you to read that first sentence up at the top of the page, the one I kind of skipped over. I went straight to the problem. It says data can be displayed in a two-way frequency table like the one below. I may have actually read it. But see, this is a two-way frequency table because it's telling me who passed, who failed. Okay, that's telling me one thing. Then it's telling me who took the class and who did not take the class. That's telling me another thing. Those are two things. So, a two-way frequency table or a contingency table displays the frequencies of data in two different categories. You can use them to organize data and identify sample spaces to approximate probabilities. So we're going to use a two-way frequency table. So if you look at this frequency table right here, we have those involved in activities and those not involved in activities. Okay, so we're looking at extracurricular activities, and then those that are males and those that are females. So we're looking at two different categories. All right, the table shows data about student involvement in extracurricular activities at a local high school. What is the probability that a randomly chose student is a female? Okay, female. Okay, so we can find female. Who is not involved in extracurricular activities. So a female that is not involved in extracurricular activities. Okay, so we're talking about this whole pool of people. Okay, so that is the probability of a female that is not involved. All right, so that's going to be 120 out of the total number. If you go down to the bottom right-hand corner, that's always going to be your total number. If you look at the problem we did earlier, the total number was 80. Remember? You can add the 50 and the 30 and get 80, and you can add the 39 and the 41 and get 80. This one the same way. 251 plus 265 is 516, and 257 plus 259 is 516. All right, so let's take that and put it in our calculator. So we're going to put 120 divided by 516, and we're going to see what the probability is of a female that is not involved. All right, so what did you guys get? 0.233, so we're going to say approximately 23%. Okay, the probability that a student is a female who is involved in extracurricular activities is about 23%. Why did I say not? Why did I say involved? I didn't mean to say involved. I meant to say not involved. I didn't mean to say that. It's not involved. All right, problem number 2. All right, so that problem and that information was located on page 850. And now this information, problem 2, is going to be located on 851. All right, the probability that an event will occur given that another event has already occurred is called conditional probability. You can write the conditional probability of event B given that event A has already occurred. And you read it as the probability of event A and given event A. All right, so we're going to find probability. All right, so we're going to look at an opinion poll. Respondents of a poll were asked whether they were for, against, or had no opinion about a bill before the state legislature that would increase the minimum wage. So we have they're for it, they're against it, they have no opinion, and then we have all their ages on the left. So this is a two-way frequency table. What is the probability that a randomly selected person is over 60 years old? So let's circle that one, over 60, given that the person had no opinion on the state bill. So we're assuming that the person had no opinion. We're given that information. So that's all we're looking at, is the one with no opinion. All right, so look, how many people that were over 60 had no opinion? That's 40. So we're going to put the probability over 60 with no opinion. All right, so it's going to be 40 out of the total number that didn't have an opinion is going to be 100. Of course, you could reduce this like this. 2 goes 2 and 2 goes 5. And then we know that 2/5 is 40% or 0.4. So 40%. 40% of the people over 60 had no opinion. All right, so what I did down below is I just did the 2 got it problems that you need to do. Got it problem number 1 is on page 851 at the top if you want to look at it in your book. Got it problem number 2A, and make sure you do 2B. You'll get 3 points for each one you do, and then I'll just give you a free point. What is the probability? And then also do the reasoning. So you're doing both the 2A and 2B. If you want more problems, here are the other optional problems. You do not have to do them. They are optional. Just make sure you upload your 3 Got It problems. All right, so this concludes new material for Geometry Honors. What you're going to be doing tomorrow is you're going to be doing the Chapter 13 review. And then on Thursday, you're going to take the Chapter 13 test. And then on Friday, we start our course review because we all know that we need to review a little bit of information because we don't know when the EOC is going to be given to you next year. If it's going to be given to you at the beginning of the year or if they're going to wait and do it when the other geometry students who are taking geometry next year are doing that. So if you have any questions, you can message me on Edmodo or Remind or send me an email. All right, you guys have a good Tuesday. Talk to you later. Bye. Miss y'all.